Simplify expressions with rational exponents, Part 2. So recall the exponent rules that we learned about previously in this course. Well, before we were dealing with just integer exponents, but now that we're comfortable with rational exponents, we can actually apply all of these rules with exponents that now have fractions in them. And that's really the goal of this video, is to get comfortable with using these rules when there's fractions involved. So let's just start working through examples to see this. X to the power of a half times x to the power of 6. What exponent rule lets us combine these? Well, the bases are the same. Each of these powers has an x as a base. So this would be x to the power of, well, we have to add the exponents. This is our product rule for exponents. And to add those two powers, I would need to have the same denominators in each power. So x to the 1/2, I'm going to write this as 3 over 6 plus 5 over 6, which is x to the power of 11 over 6. And that's it. If you're not told to write that in radical form, don't write it in radical form. Just leave it as exponents. In this problem, in part B, I should say, we have z to the power of 9 to the power of 2 over 3. So it would be z to the power of 9 times 2 over 3. And my 3 will cancel with part of that 9, leaving me with 3. So that would be z to the power of 3 times 2, or 6. Here things are starting to get kind of complicated, and we start to have a few different routes to the right answer. So we can either do this as, one option would be, let me take the most direct option first, which is just to apply the quotient rule, or basically that if you have a division, x to the 1/3 divided by x to the 5/3, you can use subtraction in the exponents. So that would be x to the 1/3 minus 5/3. And if I do that, I get x to the power of 1 minus 5 is -4 over 3. But I don't like having negatives in my exponents, so I'll rewrite this as 1 over x to the power of 4/3. So that would be one route you could take. The other route is, if you don't like having fractions with exponents, because honestly it makes life kind of tricky sometimes, is we could have just rewritten this as x3 times x to the power of -5 over 3. And so we introduce that negative into the exponent just so that we get rid of our fraction, and then we could combine things and simplify to get the same result. In this example, we have a number involved, but the exponent rule is the same. We have to apply it to each item in the brackets. So we have 27 to the power of 2/3 times u to the 1/2 to the power of 2/3, which is times 2/3 in the exponents. So 27 to the 2/3, how do I simplify that? Well, let's rewrite it as 27, the cubed root of 27, I should say, all squared, times u to the power of, well, simplifying this fraction, I have u to the power of 1/3. And so the cubed root of 27 is 3. Then I still have squared. So that would be 9 times u to the 1/3. There's lots of fractions involved now. So in this example, where I want to simplify this expression with all these fractions, my preferred method is going to be to get this x with this negative exponent up into the numerator. Let's just get all these x's in the numerator together. So that would be x to the power of -1/4, and then times x to the power of +6 over 4. And now I can just go ahead and combine these using my product rule. So this would be x to the power of 3/4 plus -1/4 plus 6/4. So I have 3 minus 1 is 2, plus 6 is 8. So that's x to the power of 8 over 4, and I can simplify that fraction as x to the power of 2. This last one is a beast of a fraction. And we have this huge giant exponent up here that applies to everything inside. So how are we going to go about this? Well, basically make your life simple. Simplify what's inside the fraction first. And to do that, I'm going to take both of these guys actually up into the numerator. So I'm going to write this as 16 x to the power of 4/3 times x to the power of positive 2/3. So I'm flipping that negative 2/3 into positive 2/3 by bringing it up into the top of the fraction. And I'm going to leave the y exponent up in the top and bring up the other one, which would be y to the power of negative 1/6, all to the power of a half. And the reason I do that is just so that I can combine my powers really easily. So now I have 16 x to the 4/3 and x to the 2/3. I add the exponents, that's x to the 6/3, and y to the negative 5th minus the 6th, that would be y to the negative 6 over 6 to the power of 1/2. And now this is all of a sudden looking a lot nicer because x to the 6/3 is just x squared, and that would be y to the negative 1 all to the power of a half. And now that I have such a simple polynomial in my brackets or monomial in my brackets, now it's really easy for me to apply that 1/2 in to each part of the brackets. So 16 to the 1/2, I'm already seeing that that's the square root of 16. And then x squared to the 1/2 and y to the negative 1 to the 1/2. So I'm multiplying the exponents there. That leaves me with 4 times x, because the 2's cancel, leaving me with an exponent of 1. So that's 4 times x and y to the negative 1/2, which I'll rewrite as 4x over y to the 1/2 to make all the exponents positive.